Assalamu alaikum, good morning everybody. Welcome to the ECG workshop of the emergency. So today is a tough day, and tomorrow will be tougher, no easier, because tomorrow there will be a quiz in the end of the session. So make sure that you consult, inshallah. So today's objectives will be to understand the basic anatomy and physiology of the ECG, appreciate stepwise approach to analyze the ECG. We're going through so many of the bad arrhythmias and tachyarrhythmias, acute coronary syndrome and management, other miscellaneous ECGs. Tomorrow also we're going for pacemaker, so we will include the paced rhythm and some troubleshootings of the pacemakers because you need to identify them in the emergency. So, what are the indications for ECG monitoring? For example, a patient came to you in the emergency, and you want to do the ECG for him. What brought this idea to your mind? What was the patient coming with or complaining of? Chest pain, syncope,
irregular pulse,
dizziness, palpitation, any other things? Epigastric pain, sometimes atypical, something can happen. Headache, okay. Seizure.
abdominal pain,
Sweating, abdominal pain. Excellent. So you missed one important thing. Most important thing. Maybe because I told you that the patient came to you. Okay, the patient was brought to you. For a cardiac arrest. Yeah. So patient came with cardiac arrest, and you want to see what was the rhythm or what was the problem that the patient came with. So cardiac arrest and other important arrhythmias, chest pain, heart failure, collapse syncope, shock hypotension, palpitation, all these things, we need to do the ECG in this case. So how to monitor the heart? By ECG. And the idea was brought in the beginning by a person with the name. This is not the ECG. This is another person to get the electricity first. Because ECG is electrocardiography. So we want to get graphy or graph. Anybody's liking photography? So we want to get a graph of the electrical activity of the heart. So electricity, who was the first person to discover electricity?
Tesla, Edison.
Yeah, Edison made the bulb, but he didn't discover the electricity. You didn't, we took it in olden days in school, Franklin Benjamin, with the kite. He flew the kite in a rainy day, stormy day, and with the thunder, he felt the electricity. So he discovered there is something called electricity. Okay? You heard about this story before? Not really. All right. But it's taught like in school. When I was in Kuwait, I took it in school, and we came to know that it's wrong. Why? Because it's a kite. How a wooden kite and a rope will make him get electricity. So looks like the story was changed a little later, and they said, okay, he put a key in the rope, and he made this rope of silky material that, some material that conducts the electricity. So he felt the electrical activity transmitted to him. Made little sense, but then they brought a practical test. He was put to practice, and they connected the same thing in a rainy day for a dummy with voltmeter. And of course the voltmeter showed tens of millions of amperes of, so he actually, if he did this, he will not only feel the electricity, he will die actually. So it was not him who discovered the electricity. The electricity was already known from long time before. Pharaohs. This is Giza power bulb or plant. They used to use the electricity long time back. And this is an ancient battery. Was discovered in Babylon, in Baghdad. Okay, if we say this, do you know this person who discovered gravity? Newton. Excellent. So how did he discover it? You know the story.
The apple
This
fell on
thing.
him.
So how did he discover it?
Apple fell on him.
The apple fell on him, and he discovered the gravity. Yeah? It's another story. It's a cute story. So yes, because the things used to fall on many people before, not only the apple. So gravity was discovered 2,000 years before him in India by Indians. Then 1,000 years later by the Arabs. But then when the apple fell on him, then he started going into the theories and laws of gravity. So he's the one who made the laws of gravity, but it was discovered long time back before. Anyways, so to come back to the electrocardiogram, this is the first ECG machine. And the person who discovered it, Enthoven. Okay, Enthoven, do you remember something with the name Enthoven in ECG?
The triangle.
Triangle, excellent. So Dr. Enthoven, he's a physician, was in love with cardiology, and I mean with love in the heart, because that time there was no cardiology. So he wanted to see what is wrong with the heart of the patients when they come with collapse, with syncope, with chest pain, palpitation, all these things. So he wanted to see what is wrong with the electrical activity of the heart. So he did simple thing that he started recording the electrocardiography. He connected electrode to the left arm, right arm, and to the symphysis pubis. Lower limbs, yes, but in the end it will be the symphysis pubis. The heart is in the center, and that time, for the electrical activity, to measure the electrical activity, you need two things. One is the amount of electrical activity, how many voltages or millivoltage. Second is the direction. Electricity is going from where to where. So he connected the electrodes in these points, and he called it Enthoven's triangle. Okay? And with this, he was able to get lead 1, lead 2, lead 3. And through this, he started to find studies started to be promoted for P waves, QRS complex, and T's. So, and he named it like this because he didn't want to start like A, B, C, D. So he made it like from P. We don't know why he started with P actually. So, big discovery, and the ECG started to be read. We can identify the patient's rhythms or heart attack or all these things. Happy? He made change to the history. That was in 1905. And because he made good history, opponents should appear. No, he's wrong. He didn't do the right thing. Why? Number one, this is not an equilateral triangle. You're wrong. So the distance between the right and left shoulder is not the same like distance between right shoulder to symphysis pubis. It's not an equilateral triangle. So this is mistake number one. You did mistake number two. The heart is not a point. The heart is an organ, closer to a lead other than lead, far away from symphysis pubis, close to the shoulders. So you're wrong. Third mistake, electrical activity here is different from here because this side is going through solid, liver. This side is going through air, stomach. So you actually did many, many mistakes. So, and textbooks till 1940, they were talking about mistakes, Entubin was wrong. But the ECG was read that time, lead 1, 2, 3, only 3 leads. And that's why if you see the senior doctors, you will find them analyzing the rhythm using, analyzing the axis using 1, 2, 3. Why? Because old textbooks used to be like this. Till famous doctor also, with the name of Wilson. Dr. Wilson, he said, guys, why are you accusing Dr. Entubin? He did something good. Why didn't you build up on him, on what experiment he did? Didn't you notice all these years that if you make some algebra and you add lead 1 and lead 2, lead 3, you get 0? So the summation of lead 1 plus 2 plus 3 equals 0. And he called it the central terminal of Wilson. So the addition of all this, summation of 1, 2, 3, is central terminal of Wilson, and it equals 0. So if you are getting the electrical activity from one point to another, I can get, this we call it bipolar. I can get the same thing, but unipolar. I will connect the 3 leads again and get the summation and compare it to this point. And I can get the voltage at the right arm. I can do the same thing, compare the central terminal of Wilson to the voltage at the left arm. And the same thing with the voltage to the foot. Now he got another 3 leads, which are unipolar leads. Very good, it's nice. But when he did this ECG, it was very small, of very less voltage. So he asked some engineers, I cannot see this, can you do something? So they played with the machine and they increased the voltages. So it became augmented voltage at the right arm, augmented voltage at the left arm, augmented voltage at the foot. Nice? Now we have how many leads in the ECG? 6. Awesome? Okay, why didn't you build up on this more? Now I know now there are 6 leads. I can add the central terminal of Wilson to any other point. Why should I limit myself only to the points of Entubin? So I will connect the ECG and I will make it according to V1, V2, V3, V4, V5, V6. Now how many leads we have?
12.
And we can get the 12 leads ECG. Yeah. Since 1960, now the ECG started to promote the other leads also, not only 1, 2, 3, also the other leads. So